In this video, we're going to look at finding the nth term of a quadratic sequence. A quadratic sequence can be written in the form un is equal to an squared plus bn plus c. Un simply means the nth term. So if you had u1, that's the first term, u2 is the second term, u3 is the third term, and so on and so forth. You might want to say u sub n, as n is subscript. So u sub 1 is the first term, u sub 2 the second, and u sub 3 is the third. The sub simply means it's a small n at the bottom just here. What I'm going to do is give an example of a quadratic sequence in this particular form. That could be, for example, 3n squared plus 2n minus 1. So I've just chosen values for a, b and c. So we can see that a is going to be positive 3, b is going to be positive 2 and c is going to be negative 1. In the video, I'm going to look at one particular way that you can find the nth term of a quadratic sequence. It certainly isn't the only way, but I prefer this particular method. Instead of just finding the nth term, I'm going to work forwards to work backwards. So at the beginning of the video, I'm going to generate the first 5 terms in this particular sequence. Once we've generated those, I'm going to work backwards to show how we can actually find that formula u sub n is equal to 3n squared plus 2n minus 1. Instead of just substituting numbers in, n is 1, n is 2, n is 3, n is 4 and so on and so forth, I'm going to split this up into the quadratic part, which is 3n squared, so that's the squared part, and the linear part, which is 2n minus 1. So let's just have two little tables and we'll generate the first 5 terms in each of those 2 parts of the sequence. When we talk about quadratic, that's just now the power of 2, or a squared. When we talk about linear, it's to the first power. You would have already done work with the nth term of a linear sequence. You would have seen that they increase or decrease by a fixed amount. So for example, 5, 8, 11, 14 is a linear sequence. And you might have been asked to find the nth term. So if we have n, we'll take the first 5. So 1, 2, 3, 4 and 5. Let's just move that on. We don't want that just there, need a bit of a space. And this is the quadratic part, which is 3n squared. If we now look at 1, 2, 3, 4 and 5, this is the linear part. The linear part now is 2n minus 1. So when n is 1, 1 squared is 1 times by 3 gives me 3. So substituting n is 2, 2 squared is 4, 3 times 4 is 12. If we substitute 3, 3 squared is 9, 3 times by 9 is 27. N is 4, 4 squared is 16, 3 times by 16 is 48. And finally, if n is 5, 5 squared is 25, 3 times by 25 is 75. So that's what our quadratic part adds to this sequence. What does the linear part add? Well, let's take n to be 1. 2 times 1 is 2. Take away 1 is 1. If we take n to be 2, 2 times 2 is 4. Take away 1 is going to be 3. At this stage, you might see that this is increasing by 2. It's increasing or decreasing by this quantity out front. So if it was 3n, it would be increasing by 3 each time. If it was negative 5n, it would be decreasing by 5 each time. So this one is going to be 5, this one is going to give us now 7, and this one is going to give us 9. If we wanted now to find the first 5 terms in this particular sequence, we would add these together. So we've got the quadratic part and the linear part. 3 plus 1 is 4. We've got the quadratic part and the linear part. 12 plus 3 is going to give us 15. We've got the quadratic part and the linear part. That gives us 32. Quadratic part, linear part, 55. And then quadratic part and linear part, 84. So these are the first 5 terms in the sequence 3n squared plus 2n minus 1. What we're going to do at this stage now is find the nth term from these numbers. So a typical question in an exam would be find an nth term formula or find the nth term of the following quadratic sequence. You'll be told it's quadratic. Clearly it's not linear because it's not increasing or decreasing by a fixed amount, and they won't just leave you to find some bizarre sequence that they've just... So for example, some maths geek in an office hasn't made this 2 to the power of n divided by 4n squared plus root n. They're not going to give you something stupid. They'll tell you that it's quadratic. Once you know that it's quadratic, you can take this particular approach. So let's start the question and find the nth term of this. The first thing that we do is find the quadratic part of this sequence. To start that, we need to find the first difference between these numbers. When I say the first difference, we're talking about what does this increase by each time. So that looks to be 11, that looks to be 17, this one looks to be 23, and this one looks to be 29. At this stage, and this is the important part because this is the part that generates the quadratic part of the sequence, we look at the second difference. We've got 6, we've got 6, we've got 6. This is a fixed amount. What we can say is that the second difference, so second diff, is equal to 2 lots of A. So from this we can state now that the value of A in an squared plus bn plus c is going to be half of 6, which is going to be 3. Let's do this and then I'll explain why it's half that quantity. So I'm not just going to tell you that and then just leave it there. What we're going to do though is generate the sequence before I add a bit more theory. At this stage, remember this above is irrelevant. What we've got now, we're not using any of this. We don't know any of this. This is all we were given. You know, it's not as if they're going to tell us what it is and then get us to work it out. So n, we build a table 1, 2, 3, 4, and 5. We're given the term in the sequence, or if you like, you could write this now as un. Really doesn't matter. I'm going to write now that it's just the term. We've got 4. We've got 15, we've got 32, we've got 55, and we've got 84. What we're going to do now is write in here, we've established that A is 3, so we write in here 3n squared. This line here is simply going to be this line. Of course, we don't know that because we're just about to generate it because we didn't see this beforehand. So 1 squared, taking n to be 1 is 1, 3 times 1 is 3. N to be 2, 2 squared is 4, 3 times by 4 is 12. 3, n is 3, 3 squared is 9, 3 times by 9, 27. We've got n is 4, 4 squared is 16, 3 times by 16 is 48. We've got n is 5, 5 squared is 25, 3 times by 25 is 75. At this stage, I want to take out the quadratic part from the sequence, which will just leave me the linear part. Hopefully you're comfortable with finding the nth term of a linear sequence. You would have done this well in advance. So at this stage, all I say is now t, or u sub n, it really doesn't matter, t minus 3n squared. All this is saying is if I take out the linear part, the quadratic part from the overall sequence, I'll be left with the linear part. So if we do that, what we're going to have is 1. That's just 4 minus 3. 15 minus 12 is 3. Then 32 minus 27 is 5. We've got on this one, that's going to give me 7. And then we've got on this one, which is going to give me 9. At this stage, we can add this part to our final answer. We've already found that. And all we need to do at this particular stage now is get the linear part. The linear part comes from these numbers here, because that's all that's left over. Remember, this is the linear part. We've just unearthed the linear part. And to find the nth term of a linear sequence, we simply look at the difference, multiply that by n, and then look at the plus or minus. So at this stage, what we can do is look at finding the nth term of this. We can see now that it goes up by 2, up by 2, up by 2, up by 2. So the first difference is going to be now 2, and we can write 2n. If n is equal to 1, what we're going to get is 2. What do we need to do to get to 1? Well, the answer is minus 1. Does that work for this one right here? Yes, it does. 2 times by 2 is going to give 4, minus 1 is going to give 3. So we can see from that, all I've done is subtracted away the quadratic part and worked out the linear part. And that gives me now this quantity right here. And we can say, therefore, and this is the therefore sign, you don't have to use that, un, or u sub n, the nth term is 3n squared plus 2n minus 1. Because once we've established what the quadratic is, then we can go ahead and take that out. So I'm not going to leave it there, certainly not going to leave it there, because we're going to do some examples. But here is what we want to look at. What we want to look at now is why the second difference at this point right here is 2a. If you don't want to watch this, perfectly fine. If we have now a quadratic sequence, u sub n is equal to an squared plus bn plus c, what I'm going to do is generate in a table the first few terms in this particular sequence. So let's go ahead and do this. So if we take now, and I need a fair bit of space, let's take n to be equal to 1, and then we'll take 2, 3, 4, and 5. So what we'll have then is un. Well, if I substitute n is 1, this is going to give me 1 squared, so that's a times 1, which is a. Then we're going to substitute it in here, n is 1, well that's going to be 1b, so plus b, and then we're going to have plus c. If I now look at the next number, what we've got is the following. If we take now n is 2, well 2 squared is going to give me 4. 4 times a is 4a. If we look now at n is 2, that's going to give me plus 2b. And then we're going to get plus c. So all I'm doing is simply subbing in n is 1, n is 2, and we'll do n is 3. So if we go ahead and do that, let's take n to be 3. Well, 3 squared is 9, that's going to give me 9a. And then we've got now 3, that's going to give me 3b, so plus 3b, so plus 3b plus c. I can keep going with these, but if I look at the difference between these two terms, what we're going to do is go ahead and subtract away. So if I look at the difference, if I take now this value away from this value, what we're going to end up with is the following. We're going to end up with 3a plus b. If I take the second from the third, what we've got then is 5a plus b. Of course, the c's are going to cancel. If I generated the fourth term, what you're going to see, and we can do a couple more terms, it really doesn't matter. Subbing in 4 squared is 16, so that's going to give me 16a plus 4b plus c. If we take the third from the fourth, what we've got is 7a plus 1b. So we can see now that taking these away is just going to simply give us now. So if we take them away from here, and we can work backwards or we can work forwards, we can always see that we're simply 7a plus b take 5a plus b is just going to give us 2a. 5a plus b take 3a plus b is 2a. So we can see now that that second difference is always going to be 2a, whichever way round we do this in a quadratic. So if you're sitting there and you're thinking, well, how does that work? Why are we just halving it? Well, we can see using these values of a, b and c in a general case that we can subtract away, and we get we go ahead and get that that quantity 2a each time. So when you found the second difference, why'd you halve it? Well, there's your answer. If you don't want to know that bit, you don't have to, just halve it, and that becomes your a in the an squared plus bn plus c. I think it's also important to stress at this point that you won't always have a value of b and c. You always have a value of a if it's quadratic, but you might, for example, just have 5n squared plus 3n, or 6n squared plus 2. Don't always have to have it, but that will come when you take away the quadratic part, and it'll either leave you with a constant, or it'll leave you now with a linear sequence that doesn't have a value of c. Okay, let's have a go at. I'll just pick a couple. And we'll work through them. So, for example, we might have. Let's say we got the first four terms: 2, 7, 16, and 29. So they're the first four terms, and we're asked to find the nth term of this quadratic sequence in the form u sub n is equal to an squared plus bn plus c. So let's have a go at this. Un is equal to an squared plus bn plus c. So what we're going to do now is look at the first difference and then the second difference. So I'll write it out. We got 2, 7, we got 16, and we got 29. So this is going to be the first difference. So the first, well, that gives me 5. The second difference, what's that going to give me? 9. And then what's the next one going to give me? That goes up by 13. So let's now look at the second difference. Well, we've got that's going up, that's going up, that's going up by 4, that's going up by 4. And we will assume, well, we can assume because we're told it's a quadratic, that that pattern will continue. So what we can see from here is that the second difference is 4. Therefore, from this, and we can write, if the second difference is 4, therefore we can say the value of A is going to be half of this, which is going to be 2. At this stage, remember, we just take the second difference is equal to 2A, and we just set up a little table. You certainly don't have to do a table, I just prefer it to keep my work nice and neat. So we've got n, we've got 1, 2, we've only got the first 4 terms. This one, it really doesn't matter. We're not told well, we are told it's quadratic, so we don't have to start thinking, well, is the 5th term going to follow this pattern? If we're told it's quadratic, the person who wrote it should be behaving and be fair to us on this. So this, remember, is the nth term, or if you like, just the term. Often we write t as the term. So what we have is 2, we have 7, we have 16, and we have 29. Let's make that 7 look a bit more like a 7 and less like a 2. So at this stage, we're going to introduce an squared. So remember, this is 2n squared, as we just found the value of a. So taking n to be 1, 1 squared is 1. 1 times by 2 is going to give us 2. Then what we've got here is going to give us now 2. 2 squared is 4. And then we've got 4 times by 2, which is going to be 8. We've got 3. 3 squared, well, that's going to give me 3 squared is going to be 9. 2 times by 9 is 18. Then we've got 4. 4 squared, that's going to give me 16 times by 2, 32. So at this stage, what we're going to do, we found the quadratic part. We've just generated the first 4 terms of the quadratic half of this. And now all we're going to do is simply do t minus 2n squared. So if we do that, subtracting down, that gives me 0. That's going to give me negative 1. This is going to give me negative 2. And this is going to give me negative 3. So what we've got then is the quadratic part we're sorted. So let's go ahead now and just highlight the quadratic part. All we need to do is find the linear nth term of this particular sequence. So we can see now that this is going to be decreasing by 1 each time. So what we've got then, definitely the nth term will start off now negative 1n or negative n. So when n is equal to 1, this is going to be negative 1, and that needs to get to 0, so we need to add 1. So if we take 2, negative 2 plus 1 gives us negative 1. If we take 3, negative 3 plus 1 is negative 2. So all we've done from this is simply now found the nth term. And if you're thinking, well, how is he working out this to be that? Well, hopefully you've done the nth term of a linear sequence before. If not, you need to go back and revise that, because quite clearly that part, I'm taking this as that you understand it. So u sub n is equal to 2n squared minus 1n, or minus n plus 1. So if you want to check that now works for this one, you can simply substitute the numbers in. 1 should give you 2, 2 should give you 7, 3 should give you 16, and so on and so forth. So as you can see, it's not horrendous. It's not as bad as it could be. So let's have a look at another. Right, let's get another page. Let's go for 4. So we'll have 4, we'll have 10, we will have, let's get 18, 28, and then we've got 40. So we've got 5 terms this time. So we're going to be asked to find, and we'll be told it's quadratic, the quadratic nth term in the form un is equal to an squared plus bn plus c. So let's write it out. We've got 4, we've got 10, we've got 18, we've got 28, we've got 40. First difference. This should now hopefully be sort of second nature. So first difference, 6, 8, 10, 12. Second difference. So second difference, we've got now, what's that going to be? 2. So 2, 2, 2. We can say second difference. So second difference is equal, that does say difference is equal to 2. Therefore, now we can say that on here, the value of a is going to be 1. All we do is half it. We've seen that in the previous example. We've got here the value of a is 2 because it was 4. In the previous example, the value was 3. There's no pattern to this. I'm just picking examples of quadratic sequences. So don't think the next one is going to be 0, because that would be pretty boring. It would be a linear sequence if it was. So let's go ahead and set this up. So in a table, and if you want to pause this at this point and just do it yourself, you might be comfortable with that. That's not straight, but we won't worry too much. Let's just go ahead and put these in. So n, we got 1, 2, 3, 4, and we got 5. What I'll do at this stage is put un, or the term we're given in the question, 4, 10, 18, 28 and 40. We know that it's going to be a is 1, so we're going to have n squared, just 1n squared. So let's generate the terms, nice and straightforward. These are the first 5 square numbers. So 1, 4, 9, 16, 25. We need to take this away to give us our linear part. So t minus n squared. 4 minus 1 is 3. We've got 10 minus 4 is 6. We've got on here 18 minus 9 is 9. What's that going to give me? 12. Hopefully this is going to, I don't know why I'm doing this, in terms of asking myself, it should be going up by a fixed amount. If it isn't, check the values. So all we need to do at this point right here is simply find the nth term of this linear sequence. It's linear, it's going up by a fixed amount, and it is increasing by 3n each time. So before we do that, let's just, okay, you don't need to highlight this, I just like to think, well, that part's going in. Now we need the linear part. The linear part, so definitely it's increasing by 3 each time, so we'll have 3n. Well, 3 times by 1 gives me 3, 3 times 2 gives me 6, 3 times 3 gives me 9, so that is it. There is no plus c. So as stated, you won't always get a b and a c, but that's what we've got. So we can just simply say from this point here that un is going to be n squared plus 3n, or if you want to be I don't know what the word is, flash, or n plus 3, n plus 3. If, for example, a more challenging question, it might say show that that linear sequence can be written as u sub n, or un is equal to n multiplied by n plus 3. I don't know that it would, but nevertheless, it's something slightly interesting. Right, we'll do one more, and again, if you want to do this yourself, you can do. So let's do 4.5. We'll go for 6. So we'll go for non-integer, so non-whole numbers. 4.5, 6, 8.5, 12, 16.5. So hit pause, have a go at it, see what you can do, and then hopefully mine will match yours. Either you're right and I'm right, or I'm right and you're wrong, or you're right and I'm wrong, or we're both wrong. But we'll have a go at it. So first difference we look at, I'm not going to put a cloud around it, I'm just going to go straight at it. First difference, 1.5. So 1.5, 2.5. 3.5, oh this is working out okay actually, and then 4.5. Second difference, so let's now write second. Second difference, let's look at this right here. Well, that's going up by 1, that's going up by 1, that's going up by 1. Therefore, what we need, and don't be afraid of this, we just halve this. The value of A is going to be equal to half of this, which is going to be now 1/2. So, straight in with the table, and we'll go ahead and do that. So let's do this, let's put the table up, and we will get those terms. So you might want to use a calculator on this, no issue if you don't, it's perfectly fine, it shouldn't be too crazy. So what we've got is n, we'll do 1, 2, 3, 4 and 5. We've got un, or just t, we're given that's 4.5, we are given that this is 6, we're given this is 8.5, we're given this is 12, and we're given this is 16.5. So what we're going to do is 1/2, remember this is the an squared bit we're going to take out, 1/2 n squared. So if we square this and half it, that's going to give me a half. You could write these as fractions, entirely up to you. On the next one, 2 squared is 4, half of 4 is going to give me 2. Let's write in this. What's this going to give me? 3 squared. 3 squared is 9. Half of 9 is 4.5. Half of 16, that's going to be 8. And then half of 25 is going to be 12.5. So what we need to do is t minus the 1/2 n squared, so we can take the quadratic part out. That's going to give me on here, let's have a look at that one. What do we end up with? Right, this is going to be 4, this is going to be 4, let's check that, that's right, this is going to be 4, this is going to be 4, and this is going to be 4. Here is the nice part now. What we have is a constant. So in the bn plus c, the linear part of this, we don't have a value of b. So it's just a constant, which is lovely. So what we can put now, this is not increasing by any amount. So it's just 0n, and then all we're doing is adding 4. So all we do is simply write that it's going to be this part, the quadratic part, 1/2 n squared, and then the linear part. Clearly I'm not going to write 0n, we're just going to put that the nth term of this quadratic, let's just go ahead, let's get that's the one I want. un is going to be equal to 1/2 n squared plus 4. And if you want to check it, check that it works in the original. This is the original just here. So if we do 1/2 of 1 squared, that's going to give us half, plus 4 is 4.5. If we do 1/2 of 2 squared, well that's going to give me now 2. 2 plus 4 is 6. 1/2 of that squared is going to give me 4.5. 4.5 plus 4 is 8.5, and you can see that that looks good. So there we go, one method of finding the nth term of a quadratic sequence. Do not be scared of doing this. Simply find the first difference, the second difference, half your answer, that becomes the value of a, take the n squared part away from the sequence to give you the linear, find the linear, bolt the two back together, and write your answer using the sequence notation. UN is equal to AN squared plus BN plus C.